Do you ever look up at the stars and wonder, how did all of this begin? How did the universe, the planets, galaxies, space itself come into existence? Well, today, let's dive into one of the most fascinating scientific ideas humanity has ever explored, the Big Bang Theory. And trust me, it's not just a name of a TV show. It's the ultimate story of everything, of how our universe was born and evolved. So, let's start at the beginning, or at least as close to the beginning as science can take us. About 13.8 billion years ago, the universe wasn't full of stars or galaxies. There wasn't even space as we know it. Instead, everything was compressed into one unimaginably tiny point. Scientists call this a singularity. Then, boom! Well, not literally a boom. It wasn't an explosion in the way you might think. More accurately, it was a rapid expansion. That singularity suddenly burst outward, stretching space itself faster than the speed of light. This moment is what we call the Big Bang. It marked the very beginning of the universe as we know it. But here's the wild part. Time itself didn't exist before the Big Bang. Space didn't exist either. This means asking what happened before the Big Bang doesn't really make sense because there was no before. Instead, scientists try to explain it with theories, like quantum mechanics, suggesting that bizarre fluctuations at a microscopic level could have jump-started the whole thing, or multiverse theories, where our universe might just be one of countless others bubbling into existence. We may never fully know, but isn't it fascinating to imagine? Now, back to the Big Bang. In seconds, fractions of a second, the universe expanded, cooled, and started transforming. At first, it was just incredibly hot energy. You wouldn't recognize it as anything solid. Particles like protons and electrons hadn't even formed yet. But within the first 3 minutes after the Big Bang, temperatures dropped enough for particles to combine and create atoms, specifically hydrogen and helium, the building blocks of everything you see today. Here's a thought experiment. If the early universe were a soup, those atoms were the key ingredients, and gravity was the invisible chef stirring the pot. As time passed, gravity pulled these atoms closer together, squeezing them into massive clouds. Those clouds eventually ignited to form stars, the first stars. And those stars? They created heavier elements, like carbon and oxygen, through nuclear fusion. These elements are crucial because millions and billions of years later, they would become the stuff of planets, plants, and yes, people like you and me. Meanwhile, galaxies began forming as clusters of stars grouped together under gravity's pull. It's wild to think about. The Milky Way, where Earth resides, came together from trillions of stars over billions of years. The structure of the universe became more complex, shaping itself into vast networks of galaxies connected by invisible threads of dark matter. Scientists still don't fully understand dark matter, but we know it's essential for holding galaxies together, kind of like cosmic glue. Fast forward billions of years, and the universe hasn't stopped expanding. In fact, thanks to discoveries like Edwin Hubble's observations in the 20th century, we know the universe is expanding faster than it used to, driven by an enigmatic force scientists call dark energy. Think of dark energy as the opposite of gravity. While gravity pulls stuff together, dark energy pushes space apart. And yes, it's as mysterious as it sounds. Now, here's an astonishing fact. Every single atom in your body, from the calcium in your bones to the carbon in your DNA, originated in the hearts of ancient stars billions of years ago. You, me, everything around us is made of stardust. Isn't that incredible? So where does this leave us today? The universe is vast beyond imagination. Billions of galaxies stretch across trillions of light years. But despite all our advancements in science, there's still so much we don't know. What's beyond the observable universe? Will the expansion ever stop? Will the universe collapse in on itself like a reverse Big Bang? Or will it stretch out into infinity? These questions spark endless curiosity and remind us of how much there is still to explore. Here's the takeaway. The Big Bang Theory isn't just about how the universe began. It's the starting point of a journey of discovery for all of humanity. It shows us that from a singular point, everything we know unfolded. And perhaps most importantly, it tells us that we're all connected, not just to this world, but to the cosmos itself. So next time you glance at the stars or feel the wind on your face, remember, you're part of this grand cosmic story. And who knows, maybe one day humans will uncover even deeper truths about the universe's origins. Until then, stay curious, because there's always more to learn.